2, 3.
4 absent and 2 checked in, but in the library. So, header 8. Homework. I'd said homework hack. Probably be a good idea to just do those analyses as a table. Do it like a table because then you get to kind of cheat your way across and just write all that stuff once, kind of like we were doing yesterday. So first of all, we got to make sure, hopefully you got your graphs right. Like, you know what the graphs look like, you should be able to just dump them in your calculator. After that, we should be getting to the point where, we can now look at it and just know. All of chapter 1 was about how do I test them? How do I prove it if I don't know just by looking at it? Like, if I got this weirdo over here, can you still deal with that? I think it hits 0, 0. So how do I prove it? Well, I can put zeros in for y and x respectively to get my x and y intercepts. If I confirm that it's at 0, 0, then I know the start or end point for my domain and range. If I never see a break in it, then I know my continuity. It's going to be continuous from that point forward. All of that stuff that we spent chapter 1 doing, you can now puke it out in one shot like that. Okay? And this is something that we don't go in depth with in Algebra 2. We introduce you to the concepts, but not this in depth. And I think now we're there, where I can throw any random function at you, and you can now tell me this stuff about it. And if you're not sure about the stuff, you can test it to be sure. Okay? So, A and B, the first and last ones, were the exact same. The functions weren't the same, but all of their stuff was the same because they were both different variations of the butt crack graph. Ignore my scribble down there where F became G in the limit. But y'all had any questions about those, analyzing them? Yes, ma'am?
For the second Z, like the G of X, what's the continuity name?
Oh, for all real numbers. An upside down A means for all. Ironically, when you put a circle around it, it means anarchy. And I could get into all kinds of philosophy about that, but I won't, because that's indoctrinating children. So, it just means for all. Continuous at all real numbers. Anything about it? Cool? Okay. We'll hand out some reviews. What? I just grabbed the whatever's available in the copy room. You always get this one.
I know, because I don't know what to do.
So you get whatever color's left. Yeah, I've got about, at this point, I'd say I probably got 6 or 8 different forms of the test, so it's no biggie about if you can't take it now, if you were gone for a day and you haven't caught up, anything like that. I just give you a different form of the test. Okay. I do them in flights. I do them by day, where no, you're not going to be able to send the sacrificial lamb to go check out the test before you take it, because everyone's getting a different form if you come take it at different times. So, I mean, you get open notes, open everything, but you still got to do it. This guy. Starting with piecewise functions. That's where we left off in the middle of 1.5. we should now be able to graph anything. And I'll tell you right now, whatever is here, probably not going to be what's on the form of the test that you get. Because, go to the first part of 1.5, that very first slide, look at all those parent function types. You had the constant function, you had a identity or linear function, quadratics, cubics, quartics, quintics, hexics, you can keep on going. There was square root, cube root, fourth root, there's absolute value, greatest integer. Y'all remember how to make greatest integer, the step functions? All those little closed circle, line, open circle, step, step, step. Okay, so you've got all of the types of functions. Your piecewise graph is going to be some combination of them defined for a specific domain. And we said that the easiest way to do these is to just graph the whole thing and lightly, and then erase the parts that don't matter. So, absolute value, okay, it's kind of light up here. This is a screenshot of an old copy. I didn't type it myself. So, negative absolute value, x plus 4 plus 5. By all of our transformations. What three transformations are happening there? Vertical reflection, negative out front. What's the plus 4 grouped in with x do? Okay. Big kid words. Horizontal translation, 4 units left. And plus 5 on the outside. Vertical translation, 5 units up. So I would go left 1, 2, 3, 4. Up 1, 2, 3, 4, 5. And that's my vertex. How do I make the rest of it? Slope of almost 1, negative 1, because my vertical reflection. Okay, it depends which side you're on, right? On the right-hand side, my slope is always a times b, the combination of my vertical and horizontal dilations. And then I mirror that to the other side. So on the left side, it's a slope of 1. On the right side, it's a slope of negative 1. So we're going to go down 1 over 1, 1 over 1, 1 over 1, 1 over 1, 1 over 1. 1 over 1, 1 over 1, 1 over 1. There we go. But I don't care about it for that entire graph. Where do I actually care about this graph? Okay. It's going to give you the part of the domain that this matters. So I go to negative 7. 1, 2, 3, 4, 5, 6, 7. And I'll go put an open circle because less ink here, less ink there. Then we'll fast forward to 0, put a closed circle there. And then everything else doesn't matter. Okay. And then I continue. The next one says the square root of x plus 1. Again, I've got plus vertical translation up 1. And we'll start with a open circle there, but it just happens to match the dot where the other one ended. This is why we said the only way you can get jump discontinuity is with a piecewise function, but not all piecewise functions are going to have jump discontinuity, because sometimes one rule starts where the other stops. So from there, y'all remember your perfect square steps. Square root just does them on their side. Up 1 over 1. Up 2 over 4. Up 3 over 9. Up 4 over 16. And I connect the dots off into the wild blue yonder. And then I come back here and I double check my domain. From 0 to 9, open circle to closed circle. So I need a closed circle right here. And then I'll erase the part that doesn't matter. So, by the end of this graph, what I should actually see is open circle, line, line. I'm going to put a closed circle in the middle of this just to be safe and like make it very clear it does exist here. Off to closed circle like that. I could just, darken over the top of it. I could erase the parts that don't matter, come back over it with pen, lock it in, final answer. But these are just two of the types of functions. Are we okay doing the whole lot of them? Can you do cube steps? Can you do the greatest integer function? The step function? Can you do that if I say, wait, what if I say 2 greatest integer of x plus 4? So I'm going to start with vertical translation up 4. Color. There we go. And greatest integer is 4 until I hit the next integer. And that's a vertical stretch by 2. So instead of going up 1 box and the next step, I'll go up 2 boxes to the next step, 2 boxes to the next step. And then I'll do the same that way. Okay? They're not difficult, it's just, I don't know if you've seen that since Algebra Half or Algebra 1, and even then, it was probably just a, hey, look at this! And then you never saw it again. So, you got that whole gamut of parent functions, the transformations to them. That's all this is. This is just, hey, can you graph it? So, notes to put to yourself. What are things that we got to worry about here, that we got to be careful about? Open and close circles. Those get kids. It really sucks to do the graph perfectly and then miss your closed circle at the end of it and just draw an arrow that keeps going. Okay? Pay attention to the domains on them. When it's open and closed circle, when you go off to infinity or not. Don't assume that they're going to connect. Don't assume that because the first rule went to -1, the second rule is going to start at -1. Sometimes there's a gap between them. It won't start until +1. Okay, so just pay real close attention to the domains of them. All right, find. Not going to have you do the whole lot of them. F plus G is usually just combine like terms, and we're easy with it. F times G is distribute, just don't distribute like freshmen. So what I'm going to focus on, and I think I have this for every form of the test, is F minus G, because we have to be careful with our negatives. And F divided by G, because we might have to deal with compound fractions, we might have to reduce, a rational expression, who knows what. Okay? So, if I got F minus G, I take the F rule, which is 1 over x minus 3, the G rule, which is x squared minus 9, and F minus G of x is this rule minus this rule. You got to clean it up. Now there's options here. Option 1, I just write it. -x squared plus 9 plus 1 over x minus 3. This is called a partial fraction decomposition. We're going to get to these at the end of chapter 6, where you're going to take a big honkin' rational and you break it into its parts like this. Because you already know how to go the other direction, which is, y'all remember with rational functions, needs a x minus 3, needs a x minus 3, needs an x minus 3, needs a x minus 3. If I want to combine into a single rational. So then if you wanted to take it that far, that's a negative x cubed, what's that, plus 3x squared, plus 9x, minus 27 plus 1 is minus 26, all over. Now they're all over x minus 3. So you know how to do common denominators with these. We worked with these in Algebra 2. We worked with them in Algebra 1. What we're going to do later in this class is we're going to work backwards. You're going to be given yellow, and you have to make a system of equations to make green. Okay? So I'll take either one. I'm just putting them both up there so you see they are both correct answers. Yes? Minus 27 plus 1. Ha! Defense! I kind of got like 6.5 hours of sleep. Bring it! The other one, f divided by g and g divided by f, this is going to make a compound fraction. I know y'all hate fractions, but dividing by fractions is easy as pie. This is the only thing I remember from 2nd grade. Flip the second and multiply. Okay? If I've got... That's not true. I actually remember a lot from 2nd grade. Like, it's traumatic. 1 over x minus 3 is f. Stop that. G, and g is x squared minus 9. There we go. When I divide by something, I really multiply by the reciprocal. So this becomes 1 over x minus 3 times 1 over x squared minus 9. Because this is all that junk over 1. So its reciprocal is 1 over that junk. Now I need to distribute on my denominator, combine like terms where possible. Getting 1 over x cubed minus 3x squared. What's that? Minus 9x plus 27. Who do what?
You just times the lines.
Yep. Distribute.
Why can't you cross multiply?
Cross multiply? Oh, cross multiply is when it's equals. A over B equals C over D. I cross multiply. When it's A over C times B over D, I can cross cancel because they're going to end up numerator over denominator. You know, I like those questions. I talked to a couple of your parents last night and said, it's the little things. It's the little question of clarification that is the difference between I kind of get this, I mostly get this, and bring it math. Okay, it's those little bits of clarification. Now, this is not the end of the problem, as some of you have seen, I am going to be handing back some tests while you're doing the other tests. Y'all, it's not big honkin', I have no idea what's going on kind of problems. It's, I missed a negative. I scored like a freshman. I didn't read the rest of the directions. Find the domain of each. Okay. Contestant 1. Who's not allowed to the party? 3. Whether I write it as green or yellow, both of them are going to say x minus 3 is a denominator. Thou shalt not divide by 0. My domain, negative infinity to 3, can't touch us. 3 to infinity. Always do that parenthesis union on top of the guy who ain't allowed there. Who's not allowed for the second one? Because that polynomial is kind of big. Okay, you can always go back to its factored form, that here's a x minus 3, here's a x minus 3, x plus 3. So this is the simplified version of my answer, but I can look at the factored form for who's not allowed on that denominator. Because that's exactly how we would do it. We would set it equal to 0, you would factor, you'd find this. So I have to exclude negative infinity to negative 3. Can't touch us. Why? Ahoy? Roger that. I believe so. Will do. Okay. Negative 3 to 3. And union 3 to infinity. So we've got to plop a union on both of those. Okay? We good? Okay. You're reasoning through. I didn't want to interrupt that. Like, you're figuring it out. What? Oh, sorry. So, number 3 says go find fog and goff and fog 3 of the functions from number 2. So you're going to use the exact same ones, coded the same way on your test. Fog, f of g. F of a thing says 1 over the thing minus 3. The thing is g of x, because I always put g into f. I work my way backwards up the chain. It's like those food chain diagrams that you see. You know, the whale eats the shark eats the tuna eats the mackerel, all the way down to the worm. Okay, I put this one into that one. G of x was x squared minus 9. So I just simplify. I can't simplify what's inside the parentheses, so the parentheses go away and I get 1 over x squared minus 12. I moved up so I could see the functions. Does it say to find the domain of this too? No. What would it be? Who's not allowed to this party? A little bit better. Plus or minus square root of 12, but not 12. 2 root of 3, because 12 breaks down into 4 times 3. You just simplify the radical. Okay? It is plus or minus square root of 12. We just make sure to simplify it. Okay. Just good practice. G of a thing says square a thing and subtract 9. If thing is 1 over x minus 3, be careful that when you square a fraction, it's a fraction of squares. You square numerator and denominator. Okay? So if I square 1, well, 1. If I square x minus 3, if you need to write out the binomials and distribute it so you don't square like a freshman, then maybe you should write them out. Or if you remember the trick for them, square the first term, square the second term. And then when I distribute, I'm going to have 2 of that middle term that will combine. So I multiply the two a and b items and double it. Negative 3 times x is negative 3x, double it is negative 6x. We tried showing you that in Algebra 1 and everyone said, screw it, I'm just going to FOIL anyway. Okay? It's just a mental math trick that makes it go faster. And then minus 9. Again, I'll take it like this. What? Excuse me, ma'am. One of them is on the denominator, the other one is up here in regular town. I beg your pardon, sir. No, we don't do that. Okay, T'Challa meme. We don't do that here. No, I can't cancel out the 9s because one is on denominator and one is not. If it helps to see it like this, okay, so they just can't. They're not in the same dimension. I could also multiply and get this. I could combine this as a single rational expression by common denominators. I'm not going to make you. You can. That would be the prim and proper, like, $3,000 a plate tuxedo dinner kind of form to write it. But I'm okay with this. And then it asks for, no, f of x, there we go. What is it? G of f of g, f of g of 3? Okay, so you got two options. Option 1, if I want fog 3, says, well, I've got the f of g rule. I can just dump it in there. 3 squared is 9. 9 minus 12 is negative 3. Negative 1/3. Ta-da! Sometimes using the rule is easier than the method that most of you learned in Algebra 2, which is to chain them together. To chain them together, you're going to take 3 and plug it into G. 3 squared is 9. 9 minus 9 is 0. Now take 0 and plug it into F. Still getting negative 1/3. Okay? You have choices. You got choices. I don't care which one you do. I will tell you, in the past, there's been a lot of kids who have done f of g, g of f, completely forgotten the evaluation. They've just forgotten that part of the problem. So please, 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 do the entire problem, underline, highlight the directions, whatever you need to do to remember to actually go find f of g of whatever number you're given. All right, find our nemesis. Inverse of, and I give you a rational. Now, in this case, I have a rational up there. That doesn't mean that's what you're going to get. Your test might have a radical. Your test might have a linear, might have a quadratic. Who knows? Do you know the inverse operation for each of those? How do I undo cubed? Cube root, right? Just like I undo squared with square root. How do I undo, well, how do I undo square root? How do I undo, oh no, we're going to do logs in chapter 3, never mind. So go find the inverse of this guy. Step 1, I set this equal to y. The function of x gets me the rule gets me the output. I will swap x and y. Getting y minus 3 over y plus 2 is x. I'll put it over 1 just for shiggles. And then, you tell me, how do we go from here? Okay. I can multiply both sides by y plus 2, which is the exact same as cross multiplying, which I can now do. I was sticky note. I can do that now, or I can do that later, depends. Either way, you need to somehow cross multiply. So cross multiply, remember to distribute xy plus 2x, y minus 3. The goal is to get that y by itself. So I want all my y stuff together. Okay? This is where some of us get the negation of what everyone else is getting, right? Because I have xy plus 2x on the left, where maybe Lori has it on the right. It depends with how you did that. Okay? I'm going to subtract y over here. I'm going to subtract 2x over there. I have the negation of what you have. It's the exact same. They're the exact same. I have this. You have this. They're the same. Okay? In either case, you want y by itself. Okay? No, that's where we ended up as a Yorkie chasing our tail. Factor the y out. Because if I have xy's minus 1y's, I have x minus 1 y's. Or see how they're almost the same thing. One's just a negation of the other. Divide. Write it in inverse function notation. And you can either have negative 2x minus 3 over x minus 1, or 2x minus 3 over 1 minus x, or negative out front, and then the 2x plus 3 up top, the x minus 1 downstairs. All three of those are right. It's just where you put your negative. Yes, ma'am.
Where did I miss the negative?
Who did what?
Where did I miss the negative?
Right here, you have a negative with your x, and then you never carried it down here. It's tiny. It looks like it's part of your equal sign. Okay, it does ask for the domain. If I'm just looking at the end result here, who's not allowed? 1. Now I want to double check that. I'm going to go back to the original. The original has domain, x can't be 2. Or sorry, negative 2. union -2 to infinity. Range, and again, this is bringing back our old stuff about rational functions. You could just dump it in a calculator and see it looks like there's a line at 1. It looks like an asymptote at 1. But because these two degrees are the same, I run with their leading coefficients. Y = 1 is my horizontal asymptote. So I will have -infinity to 1 union 1 to infinity. And I swap my domain and range for my inverse. So again, it says -infinity to 1 union 1 to infinity. But I do have to check the original. Remember, that was extra important when we were dealing with, what was it? If I went from a square root and then did the inverse and it became a parabola. Because parabolas have a domain of all real numbers, but it has to match the range of my square root. So please don't just rely on the inverse function's domain. Double check the range of your original function, just in case. All right. We also dealt with words, inverses and words. Dear God, I just saw a glare. I saw rolled eyes. I saw like a huff over here. Yo, words are not that bad. Okay. A plumber charges $50 for a service call, $40 an hour for labor. Boy, I wrote this about 8, 9 years ago because, God, what is it now? Like $100 for the service call, 60, $70 an hour. Easy. It's, y'all, you want to make money, you get yourself in a trade. You go to Western Dakota Tech or something like that, and you become certified in plumbing, welding, HVAC, whatever it is, and you're going to make way more than I ever will. So, how do I write that as a function, though? Bringing us all the way back to algebra half. Yep. Remember, y = mx plus b was often y = rate x plus start. Okay. Slope is a rate of change, so it can also be a rate of pay or a rate of cost. Now, I don't want to leave it as y = 40x plus 50 because we're going to have a function and its inverse. I would like to write this in terms of what are y and x in this problem? Not just money. They're okay. If I want to write it in function notation, I have to say, what do they mean? X is what? Hours of the service call, $40 per hour. What would y be? Not just money. Money for what? The total cost of the job. I would like to write this as the cost in terms of hours. I name the function C because the function is getting me the cost. And then I'm going to say that's $40 per hour plus 50. See what I'm getting at? Yeah. I'm also, next to this, I'm going to write what that meant. That was hours, and that was cost. So H and C column. All right, now I'm going to go find my inverse. So the function gets me the rule gets me the output. I swap. Okay, now when I swap, ooh, we talked about this in Algebra 2. I don't remember if we explicitly stated it in here. If I swap variables, when I swap variables in a formula in which the variables stand for something very specific, like C and H are cost and hours, I don't actually want to swap the variables themselves. I just solve for the other one. Because if I swap these variables, I'm going to end up swapping the meaning of them. Like I'm going to be saying C means hours and H means cost if I actually swap these. So really what I want to do is just get H by itself. Okay. Get H by itself. Who's got to go? Okay, subtract 50. And then, so now this is H equals C minus 50 over 40. If I want to write that back into function notation, now aren't I finding the hours in terms of the cost? So I'll say H of C is C minus 50 over 40. So now I have cost is my input, hours is my output. That's my inverse. Yeah, I know that we covered that in Algebra 2, but I don't know that we explicitly talked about formulas and swapping variables here. If you just have plain old y and x, go ahead and swap them. You just label what they mean. But if you have a formula where the variable stands for something very specific like this, don't swap the variables because you'll end up swapping the meaning. I would have had a function that said C of H again, but now H would have meant cost and C would have meant hours, and that just makes us go cross-eyed. Okay. Write this as a function, find its inverse, describe what it means in the context of the problem. That's why I want to write the original is hours and cost. That way I can find its inverse, which means my input is the cost, my output is the hours. That's the context of the problem. When I swapped to find the inverse, I swapped my domain and range. And then yesterday, we went on to graph analysis. 2x negative third. Okay. If I don't know what that looks like, I better dump it in my calculator. Go find it. What's that? I want domain, range. I can, yep. You don't have to. Intercept, continuity, symmetry, what else? Increase, decrease, and limits. Okay, so like Maddie's saying, remember that -3 meant it went downstairs like this? If that helps you to know what the function looks like, go ahead and do it. But what does it look like? Okay, whatever dance those two goobers are doing. Okay. Yes, it's the swooshes again. Okay. I don't know. I thought it was pretty talented. Like they're almost in sync and everything. So anyway, 2 over 1 is 2. 2 over 8 is 1/4. It's 1/4. There we go. So it's going to womp. Womp. Swooshes. Now tell me all the stuff about it. I think we pretty well beat this thing to death yesterday, even with a shortened class. Domain. Okay. Negative infinity to 0. Can't touch us. Bow, 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 bow. Range. Exact same thing, and I'm totally cool with you getting lazy and doing this. Not lazy. Economist of effort. I can tell what you mean. X and Y intercepts. How do I find them algebraically? Okay, in this case they don't exist, but how do I find them algebraically? Okay, x-intercept, plug in 0 for y. Y-intercept, plug in 0 for x. And in this case, both of them are nah. I say this because I don't remember what graph I gave you. I got a whole test bank full of these things. I just threw random crap on there. You can analyze anything now. Continuity. Is it continuous across the entire domain? No. So you got to tell me what type of discontinuity and where. Infinite discontinuity. Where? There you go. Symmetry. Okay, we had 3 kinds. There was symmetric to the x-axis, the y-axis, or the origin. This one was origin. Increase and decrease. This is where we keep having hiccups. Okay, we're headed down, down, down. Okay, and then I pick up my pencil and I'm still headed downwards. So there's just a gap at 0. This thing is decreasing along the entire domain. Negative infinity to 0, 0 to infinity, because it never increases. Remember, as you go left to right across the paper, you know, Maddie, after meeting your dad, now I understand why you have all those under your breath curses. You think I don't hear, I hear. My domain, as we go all the way left and all the way right, where is it? Both headed to zeros. So I can cheat and say plus or minus infinity. I can only do that when they're headed to the same value. Okay? And it's totally hypocritical of me to say that because you get me outside this building and any of the nerd herd that gets to go play Commander with me at the game store, the shock value on their faces. Devices off to the side, in your backpack, somewhere. I don't want to see a device until there are no tests at your table. Yes. Okay, that. I have your notes because they're right here. I need the notebook. Because remember the notebook you didn't have the name on. That's the part I was missing. Okay? Okay. So. Spread yourselves around. We got plenty of room, especially with this many kids gone.